And welcome back to section 2.1 entitled Properties of Matter. In the last podcast we tackled different types of properties like extensive properties and intensive properties. We also introduced you to the idea of physical properties. In this part of 2.1 we're going to be looking at how we describe matter, and particularly states of matter. All right, these are states of matter that you're already familiar with, but we do want to put a little bit better definition to them than maybe what you've had before. The states of matter are obviously solids, liquids, and gases. There's actually a fourth state of matter called plasma that we're not going to concern ourselves with at this point. Okay, so let's describe what a solid, liquid, and a gas is at the molecular level. A solid is a substance that has a definite shape. Oops, scribble that out. Let's go this way. There you go. Has a definite shape. It also has a definite volume, and it is not compressible or not easily compressed. Alright, now let's go ahead and draw a little square here, or cube I should say. Here is our solid. There you go. It has a definite shape because it does not change. In this case it's a cube. You could easily draw it as a pyramid or whatever else, or some type of jagged, irregular shape, but that shape does not necessarily change. And the particles are all tightly packed in a regular fashion. Now they don't have to be lined up like this, and you'll see that also in chapter 13 for those who do it, but they are in a regular pattern, and all they do is they vibrate in a fixed place. Or a pretty fixed place, anyway. As opposed to, say, a liquid. A liquid does not have a definite shape. It takes the shape of the container. Take shape of container. And what we mean by that is, let's just say, for example, you have a glass that's, well, let's just say it's going to be an Erlenmeyer flask. Okay? And the Erlenmeyer flask, you fill it up with some water, and there you go. Of course, it's not going to be wavy up top there, but it shows that you have a liquid in there. If you pour that into a cylinder, it's going to take the shape of that cylinder. Or in the case of my own kids, if you give them a straw, and they love to drink out of curly Q straws, there you go. It's going to take the shape of that curly Q as they draw the liquid out of the container. So it takes the shape of the container, no definite shape. However, it does have a definite volume, just like the solid does. The definite volume is talking about the fact that you can measure this particular volume, and as you pour it from this container to this container, if you measure the volumes, it will be identical to one another. All right. A liquid is not easily compressed itself. If you squeeze on a liquid, it's not going to necessarily shrink the volume. Not easily compressed. That's why hydraulics work the way they do. And by the way, these particles, though they are in close proximity to one another, they are allowed to move around one another. And that's a key thing with liquid. That's why liquids will flow, because the particles can actually flow around one another, although they stay in close proximity, sticking to one another to a certain extent. Now finally, gases. Gases do not have a definite shape. In fact, we're just going to say that they fill the container. If you have it in a balloon, let's just draw a balloon. Okay, the gas particles are inside the balloon, and if you were to open that balloon up into a box, Here's my box. Very quick box. Alright. Let's say you put that gas into that box, it's going to fill up this box uniformly. Alright. And if I put that into a truck, let's just make a little tanker truck here. Here's our truck. Pour it in there. It's going to fill that truck uniformly as well. So it fills the container, and because it fills the container, it does not have a definite volume either. Does not have a definite volume, VOL, volume, vol. However, a gas is easily compressible. Let me scroll down here, running out of room at the bottom. Easily compressed. In fact, if you have a particular container, you can actually squeeze. That's what plungers do. You can squeeze a gas into a smaller volume. We'll demonstrate that in class for you. Okay, so if you look at these little images down at the bottom here, hopefully this illustrates what we're talking about. A solid with a definite shape, it's rigid, a definite volume, you can measure it. Actually, you'd probably use water displacement for this particular one. We'll talk about that later. The liquid also has a definite volume, you can measure it, but the shape is the shape of the container, whether it's a cone or a cylinder or a box or a curlicues, and the gas particles will fill the container uniformly, and therefore it has an indefinite volume. You could compress it to a small volume, or if you open it up into the atmosphere, it will fill up the atmosphere uniformly. Also notice the different particles. If you look here, here, and here, you'll notice the particles are very arranged in a solid. They are jumbled up but in very close proximity in a liquid, but they are all over the place, very far apart and flying around in a gas. Okay, so those are some states of matter that if you happen to get a chance to take a look at Chapter 13, you'll learn much more about. Finally, in this section, scrolling down, we want to talk about physical changes. We've talked about physical properties, but what is a physical change? Well, a physical change is one that will change the appearance, and it could also change the properties without, again, that WO is without, changing the composition. Okay? Things like changes of state, boiling, melting, freezing, condensing, subliming, depositing. Those are all changes, physical changes, because you're not changing what they are. As you boil water from a liquid to a gas, it is still H2O. As you melt ice, H2O solid, into a liquid, H2O, it is still H2O. However, the properties do change. You go from being, say, and let's draw a picture down here. Say you go from being ice cubes to a liquid to a gas. You go from something with a definite shape to something that takes the shape of the container to something that has fills the container completely. The properties do change. Now, there are different types of physical changes. You have what are called reversible changes and irreversible. Reversible are things like boiling and condensing, freezing, and melting, because they can go back and forth very easily by changing temperature in this case. However, irreversible physical changes are things like breaking, grinding, etc. Because once the glass is broken, you can't just quickly put it back. Yes, there are ways, but that's something completely different. That concludes 2.1.